Alright, till now we have learned left-left condition, left-right conditions, and we have created left and right rotation methods for those cases. Now in this lecture we will talk about right-right condition. So as the name implies, it's opposite of left-left condition. Now let's say we have an AVL tree like this and we want to insert 75 to this AVL tree over here. So as always, we are going to compare this 75 with the root node of this AVL tree. So in this case, we see that 75 is greater than 50. So this means that we are going to continue to the right subtree. Now in the right subtree, we have 60. So we are comparing 75 with 60. We see that 75 is greater than 60. So this means that we are going to continue one more time to the right subtree. Now in the right child, we have 70. So we are comparing 70 with 75. So we see that 75 is greater than 70. So this means that 75 will be added as a right child of this 70 over here. Now after addition, we are going to check that if any of these node becomes disbalanced or not. So we are going to start from the 70. So we see that 70 is balanced because right subtree's height is 1 and left subtree's height is 0. So and the difference between them is 1. So this is balanced node. Then we are going to continue to the parent of 70. In this case, we have 60 over here. Now in this case, the left subtree's height in case of 60 is 0 and the right subtree's height is 2. And the difference between them is 2. So this means that 60 over here is this balanced node. So after finding this balanced node, the next step is we need to identify which condition is this. So as we said before, to identify condition, we need to find a path from this disbalanced node to its grandchild. Now in this case, the grandchild of 60 is 75. So the path to the 75 will be right child and right child. So this means that this is right-right condition. Now in case of right-right condition, to make a node balanced, we have to do left rotation. So in this case, we are going to do left rotation for this disbalanced node over here. So as we have identified, 60 is disbalanced node, so we are going to do left rotation for this node over here. Now whenever we are doing left rotation, this disbalanced node will become the left node and the right child of this node will become the parent of this disbalanced node. So in this case, whenever we are doing left rotation, it's going to be like this. Now after left rotation, we can easily see that this node over here becomes balanced. So in this case, our AVL tree is balanced. So in this case, this becomes as AVL tree, so this is balanced node. Now let's look at the second example. In the second example, we have an AVL tree like this, and one more time we want to insert 75 to this tree over here. So here again, we are going to compare it with root node. So we see that it's greater than root node. We are going to continue to right subtree. So here again, we are comparing it with the right subtree. We see that it's greater than the right subtree. So this means that we are going to continue one more time to the right child. So here again, we see that it's greater than right child. So this means that it's going to be added as right child of this node over here. Now after addition, we are going to check that if any node becomes disbalanced over here. So in this case, we see that 70 is not disbalanced. So we are going to continue 65. So in case of 65, we see that the left subtree's height is 1 and the right subtree's height is 2. So the difference between them is 1. So this means that it's not disbalanced. So we are going to continue to the root node. So in case of root node, we see that the left subtree's height is 1 and the right subtree's height is 3. So the difference between them is 2. So this means that this 50 over here is disbalanced node. Now after finding the disbalanced node, we need to identify the condition. Now as we mentioned before, the path from disbalanced node to its grandchild identify the condition over here. Now we can see that here 50 has 2 grandchild on the right subtree. So in this case, we need to identify which grandchild we are going to go. So the one whose height is greater, we are going to visit that grandchild. So in this case, we see that the height of 70 is 1 and the height of 60 is 0. So this means that we are going to find a path from this balanced node to this 70 over here. Now if we go, we see that we are going right and right. So this means that this is right-right condition. Now in case of right-right condition, we are doing left rotation. So this means that we are going to do left rotation for this disbalanced node, which is 50 over here. Now whenever we are doing a left rotation for this case over here, this 50 will become the left child of this tree over here. So in this case, 50 will go down with its children. Then the right subtree's left child will become the right child of this 50 over here. So in this case, 60 moves as a right child of 50 over here. Then 65 will be parent of this 50 over here. Now after doing rotation, our tree becomes balanced. So here you can easily see that if you check any of node over here, you will see that the difference between left and right subtrees of any node is not more than 1. So that's why this AVL tree over here is balanced. So this is how rotation works in case of right-right condition. Now if we closely look at these trees over here, you can see that the tree that is located on the left is disbalanced. So here the disbalance node is 50, and after rotation it becomes balanced, which performs faster than this binary search tree which is located on the left. Now let's see how the algorithm of left rotation works in case of right-right condition. So here again algorithm is look like this. So first we are creating new road based on the disbalanced right child, then we are setting disbalanced right child to the disbalanced right child's left child, then we are setting new road's left child to disbalanced node. Then at the end we are updating the height of disbalanced and new road. Now let's say we have a disbalanced node like this. In this we can easily see that this is right-right condition. So here you see that from this disbalanced node to its grandchild, the path is right-right. So if we want to do this balanced node, in this case we have to do left rotation. So the left rotation will be done for this disbalanced node over here. Now according to left rotation algorithm, it says that first we are creating new root node based on disbalanced node's right child. So here the right child of this balanced node is 40 and 40 has a right child of 50. So this means that new root will be like this. So we are creating new root based on the 40 and its right child over here. Then we are going to set disbalanced right child to the disbalanced right child left child. So in this case, this balanced right child is 40. Here we don't have any left child, so this means that this balanced right child will be set to null. So in this case, this balance becomes like this, only 30. Now after doing so, we are going to set left child of this new root node to this balanced node. Now you see that the disbalanced node is 30 and the left child of this 40 over here is missing. So in this case, we are going to update the left child of 40 as a 30 over here. Now after doing so, you can easily see that this node becomes balanced. So with this, we have successfully implemented left rotation on this disbalanced node over here, and we have made it as balanced node. Now this is how left rotation works in case of right-right condition. Now here the time and space complexity will be O1 because all we are doing over here is we are just creating a new root node and we are just updating the left and right child of this disbalanced node and new root node over here. So these are just simple assignment statements. That's why it will take O1 time complexity, and the space complexity is also O1 because here an additional memory is not required to perform these operations over here. So that's why space complexity is O1. Now with this we have come to the end of this lecture. So in this lecture we have learned that in case of right-right condition, to make a disbalanced node balanced, in this case we are doing left rotation. So this is how left rotation works in case of right-right condition. So hopefully everything is clear about this lecture. Now in the next lecture we are going to learn right-left condition. So see you in the next lecture.